so the first page here is more of this graphing stuff, where you have to remember all of the rules for graphing, okay? So we're going to sketch f of negative 2x, that's A, and B is absolute value plus 1. C is f of 1/2x. All right, let's start with these three. Here we go. So everybody's looking on practice test number 2.
Yeah.
And you're going to have to, on Thursday, do 5 pictures just like this. So this time, the given picture, it's right up there in the corner. So you can see it consists of a trapezoid thing and a semicircle. Now tell me what changes have happened. 2 things have happened here. Can you tell me what 2 things have happened, Jonathan?
Doesn't the width get reduced?
Okay, so it's half as wide, which means in terms of the picture that that little semicircle, instead of being 4 steps across, is just going to be 2 steps across. And everything is shrunk by a half. And then what else has happened in the problem? We have a flip. Anytime you have a negative, you have a flip. Which way is the flip? Flip is sideways. When the negative's inside, it's a sideways flip. So we have a sideways flip, and we're half as wide. So, using my original picture as a guide, the semicircle is now going to look like this. Does everybody understand why the semicircle is now on the left and smaller? Now, what about the trapezoid? Well, it's going to be on the right, and it too is shrunk. It's still 2 units up, it's still 2 units tall, but now it's only 2 units across. Okay? Everybody okay with that? Now, what about the next one? Well, 2 changes have happened again. 2 things have happened in this equation. What's happened? Okay, so it's bottoms up. When you take the absolute value, that means anything on the bottom goes up. And what's the other change? Moved up 1. So I'm going to do this in 2 steps because it's just too much for me to handle otherwise. All right, so here we go. So the first thing I'm going to do is the absolute value part. This guy is going to stay the same, and this guy is going to flip up. Does that make sense to everybody? That's just the absolute value part. Then I will take that picture and pick everything up 1 unit. Now you got made, use your blocks. You've got blocks there. Use your blocks, and that's what the answer should look like. The solid thing is the answer to the question. Anybody have a question about any of those steps? All right, what happens here? This is an easier one because only 1 thing happens. There's only 1 change in this problem. What is it? What happens? It's going to be twice as wide. Remember, gang, when the coefficient is on x, it affects width. When the coefficient is on x, not when it's out here, but when it's on the x, it affects the width, and it does the opposite. So this looks like a half, it's really twice. So that means that my semicircle that used to be 4 units across is now going to be 8 units across. So it's all stretched out. There's my semicircle. And my trapezoid that used to be 1, 2, 3, 4 across is now 6, 7, 5, 6, 7, 8 across. Same height. But now it's double in length. What do you think? Are you okay with that? So far, so good? D, problem D, has a couple of different things happening. What's happening in D? What changes? Twice as tall. That's a tall number. That's out in front. So we're going to be twice as tall. Means we're going to go all the way up to 4. And what else? 3 to the right. So that means, if I draw it in pieces, that means that the semicircle that did start at the origin now starts over here. 1, 2, 3 starts over here. And my trapezoid that did start way over here is now going to start right here. So everything, whoa, too high, sorry about that. Everything has been shifted 2 or 3 units to the right. Now I gotta make it twice as tall. So it's gonna come all the way up here. Twice as tall. And twice as far down. So I moved it 3 units to the right, just counted blocks, and then made it twice as tall. Anybody have a question about that one? The last one is probably the hardest because there are 3 things happening. What all are we doing to this problem? We're making 3 changes. What are we doing? Jonathan?
You're mirroring.
Okay, so this means, this absolute value in that location means mirror right onto left. Okay, what else?
You're doubling the height.
Doubling the height, so twice as tall.
You're flipping.
Which way? It's a flip. Anytime there's a negative, there's a flip. Which one's this? This is upside down. Okay, everybody got it? Those are the moves that are being made. So I'm going to start with this mirroring thing. So I draw the right side of the picture. There's the right side of the picture. Now I mirror that onto the left. So that takes care of this right here. That's taken care of now. But I need it to be twice as tall. So instead of just going down to 1, these little circles are going to go down to 2. So now it's twice as tall. But then I need to turn it upside down So the blue is the actual answer to the question. I did it in steps. I'll erase all the rest of this. The blue is the actual answer to the question. There's a lot going on there. Anybody have an issue? Okay. All right, then here we go. Now we have a page of word problems. So our test is going to look just like this. It's going to have a page of graphs. Then we're going to have a page of word problems. All right, so what are the word problems? Well, the very first one is our box problem. Now, I'm not going to trick you. You're going to have a piece of paper. You're going to cut out the corners. The size of the corners is going to determine the volume of the box, okay? Just like we've done. It won't be any different. The only thing that'll be different is the size of the paper. This one happens to be 10 by 16. So you're going to be asked to do three things. Same three things we've been doing. Write an equation for the volume. This is the equation you're going to type into your calculator. What is the equation for the volume? 16 minus 2x times 10 minus 2x times x. That equation never changes. It's dimension minus 2x, dimension minus 2x, x. That's the equation. Now, what's the domain? Tell me what the boundaries for x are. This one never changes. What's that? That's 0. Every single time. What's that one going to be? That one changes from problem to problem. In this problem, it's 5. Because what's our rule for finding that one? Half the smallest dimension. So the smallest dimension is 10, half of 10 is 5. Now, we type this in on our calculator, and when we set up our calculator, what's this number going to be? What are you going to put? Where are you going to put the 0? X min. Where are you going to put the 5? X max. Y min on these box problems, Y min is always 0. Y max is, we don't know, guess a number, like 100 or 200. Sometimes the number you guess, sometimes the number I guess, doesn't work. When we say it works, what we mean is, when you hit graph, what are you supposed to see? The top of the hill. So you have to see on your screen, you have to see something that looks like this. Because this is the point you are looking for. Now, be sure that you have typed in this equation. It may already be in there if you're using one of my borrowed calculators. And then set up your window and hit graph. Do you see a hill? Those of you who aren't doing it are absolutely the laziest bums on the face of the planet. This is a test question. Let's practice. Luke, get the calculator going. Okay, did you see the top of the hill? All right, Camry, what Y max did you use that worked for you?
200.
She used 200. Now, could you use a different number? Yes, but if you're having a hard time seeing the top of the hill, try 200. She says that works. Now, does everybody see a hill? How do we find this point then? Now, I'm gonna be really picky. I'm not gonna, this zoom and tracing thing's not gonna work. You need to use the maximum feature of the calculator. So what do you press? Second count. And then you choose, you got lots of options, choose maximum, because that's what this problem is about. We'll do our left bound, right bound thing. And who's got a point for me? Because it comes up as a point. You get an X and a Y.
1.99.
So about 2 then?
Yeah.
And comma?
144.
144? Now, yeah, I remember that on this problem. Usually they come out as wacky decimals, but this one came out pretty even. So how do I answer problem C? All this stuff that I just did was to help me answer problem C, which is find the maximum volume of the box. Which of these two numbers is the maximum volume of the box?
The Y.
144, the Y. So we're going to say 144 cubic inches. If the question said, how big are the square cutouts? Then the answer would be 2, because that's the X value. That's the size of the cutouts. But it said volume, so we picked 144. Got it? All right, number 3. You had one like this on your quiz. We're going to start with $16.55. That's the cost of my meal. This is a little different than the quiz question, though. Because what's happening? You're adding both. You're adding a 7% tax and a 20% tip. No discount here. You're just adding on, adding on. So what am I going to multiply by for a 7% tax? 1.07. What am I going to multiply by for a 20% tip? 1.20 or 1.2? So you're going to multiply it all together and round off to the nearest cent. What is the answer? 25? $21.25? Does that sound right? Okay, does everybody see that that's 2 add-ons? No discounts there. Okay. How much 28% Kool-Aid should be mixed with 20% Kool-Aid? Or 20 cups of 10% Kool-Aid to get 22% Kool-Aid. All right. So we've got amount times percent plus amount times percent equals amount times percent. So let's start plugging in our things. All right, so here we go. Percentages. 0.28, 0.10, 0.22. Everybody okay with that?
Yes.
How much should be mixed with 20 cups of 10%? Do I have the 20 in the right spot?
Yeah.
Now, the blank is in this location in the equation, which means I'm going to do 20 plus X. It's the total. It's the addition. And now I'll distribute everything and multiply it all out. And I'm doing this totally in my head, which is probably not a good idea. So I'm hopeful you are going to check me. No idea, I got 40. Would somebody confirm or deny that for me? So right, Clayton? Thank you. And that's 40 cups. So I'm sure to label my answer, just like this one was dollars. And this one was cubic inches. This one is cups in this problem. All right, and one more. Find the percent of increase. Who remembers how we do percent of increase problems?
I have a question for the last one. Don't you subtract the 2 over?
I did. That's how I got 2.4. I had 4.4.
Where did you get 4 from?
I don't know. I multiplied 20 times 0.22. I could have done that wrong. All right, how do I find percent of increase? Difference over original. So what is the difference? 400? And what do I consider the original? 11.8? So I don't know, you got the calculator, divide that out, and that's gonna give you some decimal that's gonna represent a percent. So what do you come up with? 0.033, which is 3.3% increase. So there's been a 3.3% increase. Okay, so our test on Thursday is going to have 4 word problems on it. What are the 4 word problems that are going to be on the test? Box, tax, discount, that kind of problem, percent increase or decrease, and mixture, right? Okay, next page. Consider this thing as drawn. Is the picture on the paper a function? Yes. How do I know? Why? It passes the vertical line test. Okay? So Avery, we write yes. It passes the vertical line test. Is the inverse a function? No, because it does not pass the horizontal line test. So for part B, we write no, it doesn't pass the horizontal line test. So is it 1-to-1? No, because to be 1-to-1, you have to what? Pass both. So the answer to C is no, it doesn't pass both the vertical and the horizontal line tests. Now it says sketch the inverse. These are the ones where I recommend, and of course you can do whatever you want, but I recommend that you actually write the coordinates of the ordered pairs of the original. So in other words, this is the point -2, 0, -1, 2, 0, 0, 1, 1, 2, 0. Actually write the ordered pairs. Oh. Actually write the ordered pairs of the original. Take the time to do that. Because you'll remember when I do the inverse graph, when I graph the inverse, what do I do with these ordered pairs when I graph the inverse? I switch them. So instead of -2, 0, I plot 0, -2. I turn them around. 0, -2. 2, -1. 0, 0 stays the same. So there's my triangle. What used to be an upwards triangle is now a sideways because I flipped my X and my Y. 1, 1 will stay the same. But now 2, 0 becomes 0, 2, and there's my little triangle. Negative 1, 3, negative 1, 4, and 0, 5. There's my trapezoid. And there is a picture of the inverse. Now you can look at that and get all freaked out, but you shouldn't, because all you have to do is plot the opposite ordered pairs, the flipped ordered pairs. And if you just plot those and connect the dots, you'll get your inverse picture. Everybody okay with that? 4-part question. Definitely guaranteed on the test.
So the negative 1 means inverse.
That's inverse notation. That means find the inverse. Yep. Yep. So, in part 7, this will be the last one we have time for, I think. Number 7, we are actually finding the inverse. Not graphing it, we're actually finding it. So we practiced these a lot. Do you remember? So this is what it's going to look like on your test. What are you going to write first? Y equals. And the reason we want to get y equals in there is because what's the very next step? So we got to switch the variables. So we're going to make that an x, and these guys are going to be y's. Okay, now what? Move this over to here. Multiply it over to here. So you can't get rid of it over there. You multiply both sides by 2y plus 1, so it's gone. And then we distribute, so we have 2xy plus x equal to 3y minus 8. So I brought my denominator over and I distributed. All right, here comes the hard step. And it's not a hard step, it's the one we forget though. What do we have to do now? Get all the y's on the same side. So we're going to rearrange the equation, move things around so that all of the y's are on the same side and everything else is on the other side. So I move this over here and move this over here. Switch places. Now that all the y's are on the same side, what can I do? What do I do? This is a key step. I need to pull out the y. I need to factor out the y. So now that I have them on the same side, I'm going to take them out. And then I will do my division. And there it is.
Abby Bailey to the front office, please. Abby Bailey to the front office.
And that's your answer. That's what you put in the answer right. Okay? Alright, someone will need to remind me tomorrow where we stop. And we will finish this tomorrow and number 3 tomorrow. Yeah, nobody leaves the room till I get my calculators back.